Okay, so we're going to work through this. I'm going to practice using my Snagit here and hopefully it'll work. It didn't work in first, but with the 3 screens, we'll see if we can make this work. All right, first step, counting electrons. I'm going to start there with nitrogen, our first one over here. How many valence electrons does nitrogen have? 5, correct. Group 15 has 5 valence electrons. How about oxygen? 6, good. Group 16. And then, of course, chlorine is a halogen. So group 17 is going to have 7. Good. Very, very good. So this is a total of 18 electrons that we get to work with. Now, let's look here. Central atom, usually the first one, and the least electronegative, although nitrogen and chlorine basically have the same electronegativity, but we're going to go with it. So nitrogen's going to go in the center. Now, in this particular case, when it's nitrogen or oxygen, it's group 15 or 16 as the central atom. And I have 2 things to attach. I'm always going to attach them clockwise. And you're going to figure out why I do this later. So I'm going to attach the first one, O, and then the Cl like so. So I've used 4 electrons. 4 electrons because each single bond has 2 electrons in it. So now I'm down to, I've used 4, now I'm down to 14. Now I'm going to satisfy the octet of the ligands. So that's 6, and that's 12. So now I'm down to 2. So I've used 12, now I have 2 left. Extras always go on the central atom like we talked about a minute ago. So I'm going to put that there. This is where I take a look at my structure and evaluate. Is it everybody satisfied, has their complete octets? Everything okay here? Or is there an issue? Nitrogen only has 6. Yes, we have the 2, the 4, the 6 here. So we only have 6 for our nitrogen. So in order to remedy that, that means we have to create a double bond with nitrogen. Now, which atom do I pull from? Do I pull from the oxygen or the chlorine here? Which one is capable of doing double bonds? Oxygen is. Remember, the halogens only do single bonds when they're on the outside. So I'm going to take this one off right here, and I'm going to make that the double bond here. So this would be my structure. Now, everybody has 8. We have the, 2, 4, 6, 8 here. 2, 4, 6, 8 for this line. 2, 4, 6, and then 8 here. So everybody has all of their octets completely satisfied. So that's good. That's a check. Now, if we're looking at our nitrogen here, how many bonded atoms to the nitrogen? How many are bonded? How many total atoms are bonded to the central atom? Nitrogen's the central atom. We have 2, the oxygen and the chlorine. That's 2 bonded atoms. How many lone pairs on the central atom? Only 1. Now, this is important when we're identifying shapes. You need to know how many bonded atoms are and how many lone pairs are when you're trying to identify the shape, which we're going to do later. But you have to be able to recognize those, and that's going to drive what the shape is for the particular structure. And I know some of you did your PhET simulation and you might be able to, well, there's 2 bonded atoms, 1 lone pair. This one happens to be bent shape. Okay? And we'll talk about that more later on, but if you remember that from your PhET simulation, that might be something, to pay attention to. All right, so now we're going to look at the next one. And because I'm using my smartboard, I have to erase in between now. Yay, but I get to do that. Okay. All right, so now we have xenon tetrafluoride. How many valence electrons for our xenon here? 8. Good. And the fluorines, each one of them bring in how many? 7, good. So 7 times the 4, because there's 4 of them, that's 28. So this is a total of 36. Which one goes in the center? Xenon, very good. All right, central atom attacher ligands. All right, how many electrons did I just use to attach all 4 of the fluorines, those ligands? I used 8, so now I'm down to 28. Okay, now dots around them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I've used 24 of my 28. That means I'm down to 4. I have 4 left. Extra electrons go where? Lone pairs on the central atom. So it doesn't matter which side you do. You can pick any side. I'm going to put some there, some there. Now, counting the bonded atoms to our central atom. How many are bonded around our central atom? 4, good. So we put a 4 here, and then how many are there lone pairs on the central atom? 2, good. Exactly right. Now this is a shape that you guys won't have to study. I mean, this is when we do an AP, but this one actually happens to be called square planar. It's kind of interesting. Alrighty, so that's that one, good. Ozone is our next one. Does everybody know that O3 happens to be ozone? Anybody know what ozone is? Ozone? Anybody familiar? The ozone layer? No? Okay. Well, ozone's in the stratosphere, of course, blocks the UV radiation. Exactly right. Now, when we have ozone down here at ground level, though, ozone is very toxic to our lungs, so we don't want to breathe it in. But we like it up there in the stratosphere, blocking out the UV radiation so we don't all get skin cancer. So plus on there. All right, so ozone. How many valence electrons for O again? 6. Add 6 times 3 because there's 3 of them, so now we have 18 to work with. Well, guess what? Which one goes in the center? It's kind of a silly question, but I wonder, right? It has to be O. Very good. All right, so we're going to put O in the center since there's only 3 O's. And we're going to attach the other O's. This case too, O happens to be a group 16 atom, so I'm going to draw them, going clockwise, because this one's also going to look bent. And I'll explain, later on, the bent ones, it's better to draw the Lewis dot structure bent, because then it makes you realize the shape better. So for this particular one, also group 15, group 16, central atoms, I always start and do the clockwise routine. All right, I've used 4 of my 18 because I did 2 single bonds here. So I'm going to take away the 4. So now we're down to what? 14, right? 14 left? Okay. If I can count right today, I'm not sure. It is up for debate. Now we're going to satisfy the octets here. All right, I just did 12, right? So now I'm down to 2. And then I have one more up and on the central atom. Are we good to go here? No, the middle oxygen does not have a complete octet. So what do we have to do here? Double bond. Now, does it matter which O I double bond from? No, it doesn't. But what happens then so I'm going to do it from down here. I'm going to double bond it from down here. What kind of structure does this create for us though? Because it doesn't matter which O I bonded off of. So this is a resonance structure. We have to draw both. So I don't care if you don't have a lot of space, you can make it smaller, but draw the arrows. You can even go this way if you have more space this way, I don't really care. Whatever works for you. We have to draw in both structures where it's showing the double bond on the other O as well, because remember it's sort of a hybrid between the two. So I'm going to draw it like this. But, oops, I forgot my other O. Hold on a second. Need another O here. I'm going to make the double bond on this one this time. Because remember, it's really not on one particular oxygen. It's actually equally spread across all three. So that extra pair of electrons is equally spread out. It's sort of a hybrid. We call them resonance hybrids or resonance structures. But you have to show all the different representations. So make sure that in this case, we would have to show both of these two. All right, for the bonded atoms, how many bonded atoms to our one central atom here? How many bonded atoms? 2. There we go, 2. Put a 2 here. 1, 2. We have 2 bonded to the central atom. Good. Now, how many lone pairs on the central atom? Only 1. Good. This is also one of those bent-shaped ones we were just talking about. Last but not least, the polyatomic ion example. This one has resonance. We did one with a double bond, and then we did an expanded octet. So last but not least is our polyatomic ion up here, ICl4 minus. All right. How many valence electrons for I? Let's start there. I gets how many? 7. Good. How many for our Cls? Chlorine, how many for chlorine? 7 times the 4, because it's also a halogen. Now, what do we do about this thingy, this -1 charge? The -1 charge, what does that mean? We need to add an electron, so we're going to add another one in. Good, so we have 7 plus 28 plus 1. That's a total of 36, is that right? 36. Check my math on that. I think that's right. Okay. I's going to go in the middle. Let's do that. Put I in the middle. Attach the ligands just like we normally would, following the same rules as we always do. Okay. Satisfy the octets of the ligands. That's 2, 4, 6, 8. Okay, so now I'm down to 28, right? 28. Okay, can't count today. All right, so this is going to result in 24 being added because there's 4 of them that need 6, so that's 24. So subtract out 24. Now we're down to 4. All right, so now we have 4 left that we need to put on the central atom. Like I said, it doesn't matter which one you do, as long as you add it to the central atom. All right, what is the other thing that we need to make sure we add to this particular structure here? Because it's a polyatomic ion that designates it separate from like regular molecules. Brackets, we need brackets. And what else? Charge in the upper right corner here. And remember, you don't have to put a number on it because it's only it's an understood 1 if you just have a minus, but you can put 1 minus, that still would be acceptable. How many bonded atoms to our I in the center there? 4, good. And how many lone pairs? 2. This is also one of those square planar ones. I guess I repeated my shapes here. All right, so hopefully that makes you feel a little bit better about drawing, because now we're going to really get into the VSEPR stuff. Let's see if my video worked too. Hopefully it did.